Today I don't feel like doing anything, so I'm just gonna do some sequences. Let me start with some arithmetics, and then I'll jump to geometrics. Oh, and we shouldn't forget the series. I'm gonna start with finding the common difference.
Well, welcome back, everyone. We are here with arithmetic sequences and 4-6 from Algebra 1 Big Ideas. So we're going to be looking at what these arithmetic sequences are today. It's the first part of sequences. So sequences is something we will get into again later on, sequences and series. But the first one that we do talk about is arithmetic. The second one we talk about is called geometric, and that will be coming in a later chapter. So let's first just get into our little cartoon. So it's a Halloween one here. What? It's my Halloween costume. Very funny, Robin. Batman doesn't like the fact that Robin dressed up as Superman. Alright, let's get into our arithmetic sequences. Alright, on page 123 in your notes, you're going to see the vocabulary at the top, and so we'll start with just that. So just the word sequence is just an ordered list of numbers. You can write that down next to sequence there on that vocabulary. And the next one down is a term, and a term is just a number in a sequence. So that's what a term is. And so we have a sequence right here as an example. So you have the sequence is just an ordered list. So we have 5, 10, 15, that's just a sequence. You can have a sequence of any numbers. And then each sequence, each number in this is a term. So the first term, we call it first position, or you could say first term. So position and term are the same thing here. So the first term is 5, the second term would be 10, third position, third term is 15, and so on. And then the next couple are the arithmetic sequence and common difference, and you can find those right there below in the core concept. In this core concept, it has arithmetic sequence, so you can just highlight what the definition of this, an arithmetic sequence, is where the difference between each pair of consecutive terms is the same. So it's either going to go up by the same amount, or it's going to go down by the same amount. And that amount is called a common difference. So the difference there is called a common difference. So the amount that you either go up or you go down is called a common difference. And each term is found by adding the common difference to the previous term. So again, that same sequence we had here with 5, 10, 15, 20, you can see here the common difference is that you're going to add 5. Notice they didn't just put 5, they put plus 5, because it could be going down by 5. If this was turned around and it went 20, 15, 10, and 5, well then we want to say negative 5 for that because it's going down by 5. So you want to definitely know, is it a positive 5 or a negative 5 for that common difference. Okay, a couple things to notice here is that since we're in the section we're talking about linear functions and writing linear functions, I want you to understand that arithmetic sequences are linear functions. And so what we got to see here is we got to see our ordered pairs out of these arithmetic sequences. So you have both your sequence numbers here and the position number. So you have your sequence number 5, your position number 1, sequence 10, position 2, and so on. So the actual numbers in that sequence are your y coordinates, and the position numbers, or the term numbers, are the x coordinates. And so you can make ordered pairs out of these. So this would be a 1, 5, a 3, 15, and so on. And then down here when we're talking about the common difference, again, thinking about y equals mx plus b, and m being the slope. In a linear function, we have a slope of a line. Well, that common difference, in this case positive 5, that is our slope number. So our slope number of this sequence would be the 5, the positive 5. And that is because we see it's the change in the y value, or the rise. And so you can see that's what's happening here. Your y values here are these numbers, the change in the y value over the change in x, okay, which is just 1. Your change in y is 5 over 1. 5 over 1 is 5. That is the rise. That's your rise over run. Your rise is always going to be just these y coordinates because your position numbers are always going to go by 1s. All right, let's try a couple here as we get into our extra practice. All right, so there on the top of page 124, we see our 1 through 6. It asks us to write the next 3 terms of the arithmetic sequence. And we also I want to identify what the common difference is. So really, to be able to identify whether this is an arithmetic sequence, because your sequences could be any set of numbers, but to make sure that it's an arithmetic sequence, that it will line up with linear functions, you need to have that common difference. And so let's take a look at what the common difference is first, and then using that common difference, find the next three terms of the sequence. Starting with 1, so we're trying to find what our common difference is. I'm just going to put CD here for common difference. And we just can look at the from the first number to the next number. It is 1 to 8, that's going to be 7. And then we want to make sure that the next numbers are going to be 7 as well. And these are arithmetic, so we do know these are going to be all the same because it actually tells us it's arithmetic. But if we didn't know it was arithmetic and we're trying to figure that out, we can just see all of them got the common difference there. So your common difference here is going to be 7. 7 plus 8 is 15, 15 plus 7 is 22, and so on. So I'm going to put a plus 7 there for a common difference. The next number, 22 plus 7, that'd give us 29. That'd be the next number in the sequence. After that, 29 plus 7 is going to give us 36. And then 36 plus 7 is going to give us 43. So there's the next three numbers that's going to be in this sequence. I mean, obviously we could keep going, but we just need to stop at 3. Let's look at number 2. On 2, it's going from 20 to 14 to 8 to 2. And so it's going to go down in this one. Last one, they were going up. So that was a positive number there for the common difference. But this time they're going down. They're getting less every time. And so in this case, from 20 to 14, the difference there is 6, just like 14 to 8 is 6, 8 to 2 is 6. But it's a negative 6 because we're going down. So you got to realize your common difference is a negative number at that time. And so the next number, if you say, okay, 2, and then you just give a negative 6 to 2, it's going to be negative 4. And then basically negative 4 and negative 6 would make negative 10. And then negative 6 and a negative 10, that would make negative 16. There's the next three numbers in that sequence. As we look at number 3, we got 12, then 21, 30, 39. So our common difference there from 12 to 21 is 9. 9 plus 12 is 21. 21 plus 9 is 30. 30 plus 9 is 39, so on. So our common difference is a positive 9 because they are going up. So our next number there is just going to add 9 to 39. That's going to give us 48. 48 plus 9 is 57. And 57 plus 9 is 66. There's the next three numbers in that sequence. All right, so I'm going to go ahead and have you pause the video, do 4 through 6, do the same thing, identify what the common difference is, and then find those next three numbers in that sequence. And then play it, and then check your answers. Alright, so hopefully you got the answers for 4 through 6. Let's just check to see if you got these right. Number 4, your common difference is a positive 7. And the next three numbers are 33, 40, 47. Number 5, your common difference there is 4, positive 4. So the next three numbers there are going to be 19, 23, and 27. And for 6, it is a positive 12 on that one, from 2 to 14. That's 12. And so the next numbers on this one is going to be 50, 62, and 74. Alright, so hopefully that should have been fairly easy for you to do. They obviously do get harder from here. This is probably one of the easier parts of the lesson. Alright, let's move on to the next section. Alright, so on the 7 through, 12, it asks us to graph the arithmetic sequence. So we're told it's an arithmetic sequence, it has a common difference, but we just need to graph them. So this is going back to what I was talking about. We can make ordered pairs out of these to be able to graph them on a coordinate plane. We can identify these as a kind of a linear function. Even though we're not going to connect dots and make a line, we're just going to leave them as dots. So what I'm going to do is I'm going to do the even ones out of this section and have you do the odd ones on your own, and then you can check those answers once we've finished this section. But let's start with number 8. We'll do the even ones together, then you can go back and do the odds. So number 8, we have 9, 6, 3, and 0. Those are first 4 terms of the sequence. So what we can do, remember we talked about the position number or the term number. 9 is in first position, and so you can make an ordered pair out of this. And so we're going to make kind of like almost a table of values. These are our y coordinates, remember. So the actual numbers in the sequence are the y coordinates, and the position numbers, or term numbers as you want to call them, are the actual x numbers of the coordinate. So you can do it. I'm going to put a line there, and then for 9 I'm going to give it a 1. That's my x number. 6 we're going to get 2, and then 3 is a 3, and then 0 is 4. So first term, second term, third term, fourth term. These are our x numbers. So this is a 1, 9, a 2, 6, a 3, 3, and a 4, 0, as we're going to put them on our coordinate plane here. So let's draw a coordinate plane, but since everything is positive, we don't need all 4 quadrants. We can just do the one. So we can do like an L graph here, where this is all just first quadrant, all positive. And right here in the corner, we're going to put our 0. And then we're going to just number our axes. Each box will be 1 unit here. So 1 through 4 on the x, because that's all we need to go through really there. On the y-axis, we have to go all the way up to 9. So we're going to just number 1 through 9 on the y-axis. And then just like ordered pairs, this is a 1, 9 ordered pair. So 1 and 9 is going to be right up there. And then 2, 6 will be just below it. And then 3, 3. And then 4, 0. And you can see that they all line up. If we were to take a ruler, these would all line up to be a straight line. That's what arithmetic sequence is. It is a linear function with your ordered pairs. All right, let's go on to number 10. All right, so number 10, our sequence is 1, 2.5, 4, and 5.5. So again, I'm going to make a little table of values out of this, starting with the first term is our first one, 2.5 is our second term, 4 is our third term, and 5.5 is the fourth term. So that gives me ordered pairs now that I can plot here. Draw the same L graph. Everything is positive. Let's put 0 in the corner. And go ahead and number our x-axis 1 through 4, just like we did before. And then this one we need to go up to at least 6, I would say, to be able to cover 5.5. So we can do the same thing here, just go up to 6, 1 through 6 on the y-axis. And so now our first one is 1, 1. So just go ahead and plot a 1, 1 point there. 2 and then 2.5. So 2 for x, 2.5 is going to be kind of halfway up right here. So there's 2 right between 2 and 3. Next one is 3, 4. There it is. And then 4 and 5.5. So right there between 5 and 6 on the 4 there for the x. All right, let's go over to number 12. Like I said, I'm just doing the evens. You'll come back and do the odds ones. Now, number 12, our sequence is fractions. 1/4, 5/4, 9/4, and 13/4. They're all in fourths, which is nice. That's helpful. So let's go ahead and do the same as we did here. Put 1, 2, 3, and 4 for each of those fractions. So we can see these are x numbers, these would be our y numbers. But plotting improper fractions on a coordinate plane is a little more difficult. It would be easier if either we maybe made this a decimal or made it a mixed number. So obviously 1/4 we don't need to worry about. That's already as simple as I can get. But 5/4, we don't want to turn that into 1 and 1/4. 9/4, 4 goes into 9 2 times, so that's 2 and 1/4. And then 4 goes into 13 times 3 times, that's 3 and 1/4. Might be easier to graph them this way with mixed numbers. Let's go ahead and draw our coordinate plane. Again, just the L graph, as we saw before, 0 in the corner. And we're going to put our 1 through 4 again, just down here for the x. Now on this one, since we're going by fourths, and I have some space here, every 2 boxes I'm going to do 1. So every box is going to be a half, pretty much. So go up 2 boxes, there's 1. 2 more boxes, there's 2. 2 more, there's 3. And 2 more, there's 4. So every box here is going to be a half. Half and 1, 1.5, 2, 2.5, 3, and so on. So for our 1/4 here, for 1, we're going to go up 1/4. So this is half. 1/4 is half of a half. We're going to be right there. So half of the half. And then we're going to go to the next one at 2. We're going to be up at 1 1/4. So there's 1 and 1/4 is half of the half again. So just right above in that box. 3 and we're at 2 and then 1/4, which is just halfway up. And then 4 and then 3/4. Go to 3 and then half of a box. And again, you can check to see if you're correct. Look and see if your points line up. That's how you know you're correct. These are arithmetic sequences. All of them are. So all your points should line up perfectly to be a straight line. All right, go ahead and pause the video now and go back and do 7, 9, and then 11 right here. All right, and just play it once you're done and check your answers. All right, hopefully you've finished 7, 9, and 11. Let's go ahead and check your answers. Just check to see if you got these correctly done. So here's what you should have for 7. So your L graph 1 through 4, 1 through 7 is what you really need, and then there's where your points should be: a 1, 1, a 2, 3, a 3, 5, and a 4, 7. Now number 9 does have fractions, so I would again probably change those either into decimals, as I'm seeing here, as you're seeing here, or into mixed numbers. So I've changed a 15 halves into 7.5, or it could be 7.5. And then 13 halves would be 6.5 or 6.5. 11 would be 5.5 or 5.5, and so on. So that would be easier to work with the graphs. So again, you got your x and your y. Your y is going all the way to 10, because we have to go all the way up to, well, I went all the way to 10. I actually didn't need 10. I probably had to just go all the way up to 8, and that would have been fine. So at 1, we're at 7.5, which is there's 7, and then half of that box right there is your half, 7.5. And then there's the 6.5, 5.5, and 4.5. So that's what yours should look like. Again, it should go in this downward direction. This would be a negative slope, as you see here. And the common difference, as you can see, looks like it's -1, as you look at the just what the common difference would be. Down 1, right 1. That would be a -1 slope. So again, the slope number would be that common difference. So as we see, what's the common difference between these? 1 to 3 is 2. Well, that's up 2, right 1. That's a slope of 2 right there. So we have a slope of 2 going on with that line. Again, we're not going to connect these dots with these sequences. We're going to leave them just as separate dots. And then for number 11, here's what you should see. You should see a 1, 1, a 2, 4, a 3, 7, and a 4, 10. So again, common difference here was 3. So up 3, right 1 for these ones. And you can see that's where your slope is. All right, let's move on to our next section. All right, right at the top of page 125, you see 13 to 15. It says determine the graph, determine whether the graph represents an arithmetic sequence. So I talked about this before, that you can have a sequence of all sorts of numbers. It doesn't necessarily mean it's arithmetic. Arithmetic, they are the main thing there. It has to have a common difference. So you could do a couple things here. We can make sure we look at the points and see if it has a proper slope of rise over run, the same every single time between all the points, or you could look at the numbers and just see about the common difference on the y. Obviously you have 1, 2, 3, 4 for x, but the y's are going to be the ones you want to check and see, is the difference there on the y the same difference every single time, either as they're going up or they're going down. So what I want you to do is pause the video and then check this out for 13 to 15, see if it has a common difference. If it does, you can say yes, it's arithmetic. If it doesn't, then it's not arithmetic because it doesn't have a common difference. So go ahead and pause the video and then determine that for 13 through 15, and then play it and then check your answers. Alright, so hopefully you got an answer, really kind of a yes or no answer for 13 to 15. So number 13, for this one you can see that it is definitely going to be a no because it does not have a common difference here. You have up 1, right 1, and then you got up 3, right 1. That's definitely not the same slope there. So not arithmetic because it has no common difference. This one here, you can see up 1, right 1, up 1, right 1, and it's a straight line as you're doing that. So this one's definitely arithmetic. It has a common difference. If we wanted to identify what that was, then we're going by going by tens. So up 10, right 1. 10 over 1 is 10, or the difference between the y numbers is positive 10. So yes, because of common difference, and that's positive 10. Go ahead and write the positive 10 down there for that. 15, you can see this one's going down 1, right 1, down 1, right 1, down 1, right 1 every time. Definitely has the correct slope, and it has the same common difference. They're just going down. So yes on this one. What is our common difference? We're going down by 3, 21 to 18. Going down by 3 over 1. So -3 over 1 would be a -3 slope. That's a -3 for the common difference. All right, make sure you write -3 for that common difference. All right, a quick pause for our joke of the day. So what do you get when you cross a snowman with a vampire? Crossing a snowman with a vampire. Something scary, probably. You get frostbite. Frostbite, of course. Alright, so you have another core concept, and that's the equation for arithmetic sequence. That was back on 123 there at the bottom. And that right there, which this little formula, we call it a formula here, that you want to highlight. Make sure you are going to highlight, this formula down here. That's very important. Oops, no, I don't want to do that. Highlight, there we go. So highlight that formula right there. That's the formula to write an arithmetic sequence with. Okay, so make sure you highlight that. Now what's above here is just kind of showing you how to get this formula, how it's kind of formed, but it also helps us understand a couple things about some of these terms that are in here. We got some weird things going on. A, and we call it of n, and then there's a little subscript n down here. It's A of n, A of 1, and then you have an n here inside, minus a 1, and then you have a d. Well, you might know what the D stands for. That's going to be common difference. And it says right here, common difference is the D. But the A of 1, that is your first term. So the first term is A of 1. Let me highlight that part right there. First term is A of 1. And the D, there is the common difference. Common difference is the D. That's like the slope number, right? So that's what we're going to plug into here. We're going to plug those things in. And that's going to help us be able to write an equation here for this. And you can see they kind of showed you this a little bit with using the number 4 for the first term and a common difference of 3. So that's basically what they're doing there. So they'd write this out here. They would say this would be our answer right here, would be that. So 4 and then n minus 1 times 3. They're just filling in the 4 where the first term is, the 3 where the D is. And that's what they would have for an equation. Okay, just kind of writing an equation. That would be an equation that we could use right there using these numbers, 4 for the first term and 3 for the common difference. All right, so we have several to practice here on our extra practice. So let's get into those. Alright, so here are 16 and 21. This is definitely going to be the most difficult part of the lesson, is to write these equations. So we have the sequence in front of us. We're told it's arithmetic, so we know it has a common difference. And so we're really looking at plugging things into our formula. So the formula is the thing to remember. If you have the formula, then you have the tool to be able to do this with. If you don't remember the formula at some point, then you're not going to be able to do this. So you have to remember this formula or have it in front of you to be able to use. So the A of n, and that's pretty much like y equals. So it's kind of like almost y equals. And then you have your A of 1, your first term, plus n of 1. And then you got your d. So this is almost like function notation, like f of x, where n is like the x in the equation here. And so you have your first term, which is a number, and d is going to be a number. So we're going to fill those into this whole thing. And then it also says after we do that, if we write the equation, they want us to find a of 10, which means that the n would be 10. So remember f of x, this is like f of n in this case. So n is 10. So once we're done and we get an equation, we just plug 10 into that equation and then figure out what that would equal. What would the a of n equal? So a of 10. So the first thing to look at is our first term is on this one, number 16. I'm going to do a few of them. I'll have you do a few. So I'm going to do 16 right now. Negative 5.4 is our first term. Our common difference, that's what we need to figure out, is the common difference. So it's going, looks like it's going down here in this case. It's getting a bigger negative, and the common difference is definitely a decimal. So 5.4 to 6.6. That common difference there is 1.2, and since it's going down, further in the negatives. So you got to realize that this, even the numbers are getting bigger, they're actually getting bigger in the negative direction though. That's why it's going to be a negative 1.2 for your common difference. That's important not to get the sign wrong. And now that we know these two numbers, we're just going to plug those into our formula. So we start off with a of n equals, the a of 1 number is negative 5.4, so we'll write that down. So negative 5.4 plus n of 1, so that's always going to be the same there, n of 1. And then the d number for this one is negative 1.2. So now we have that. So now we just need to clean it up. We don't want to leave our answer this way. We do want to clean this up. So we want to get it more like in y equals mx plus b format. So we need to just multiply negative 1.2 times n and times 1. So again, negative 5.4 here, and then negative 1.2n would be next, and then multiply. Negative times negative will be a positive 1.2. 1 times 1.2 is still 1.2. And now we can combine like terms with the negative 5.4 and the 1.2. Those are the two that are like terms because they don't have the n. So we're going to put those two together, and so we're going to have to subtract them since they're opposite signs. So take 1.2 away from 5.4 and keep it negative. So your answer now is going to be a of n is equal to negative 1.2n, that's like your slope number right there, minus 4.2. Okay, so notice that your y-intercept is not the same thing as the first term. So this is like our y-intercept right here, negative 4.2. Next thing now is to plug 10 in for n. So we're going to be doing negative 1.2 times 10, then minus 4.2. So let's try that. So just plug 10 now in for n, and that's going to give us a negative 12 actually right here when we multiply first. Negative 12 minus 4.2, and we're going to just get a bigger negative. So you kind of add 4.2 to 12, that's going to give you 16.2. So it's negative 16.2 for the 10th term. So basically, as we were to figure out what's the next several terms, well, what's the 10th term? We have the first 4 in front of us. What would the 10th term mean? So knowing the equation is a whole lot easier to get future terms or terms further down the road. We don't have to just keep generating the next one and the next one and the next one using the common difference, even though we could. We could add another negative 1.2 to get the 5th term and so on. But it's a whole lot easier just to plug it into the formula here that we have an equation to generate. This would be my 10th term. All right, let's come down and do number 19, I think is the next one I'm going to have you do. So let's do it together, 19 right now. Negative 11, negative 9, so you can see negative 11 first is our first term. That's the number we need. And then the common difference, looks like we are going up. The numbers are getting bigger. They're going towards 0 in the positive direction. And they're going up by, it looks like 2. So they're going a positive 2 then is our common difference. And so using those two numbers, negative 11 for the first term and 2 for the common difference, we're going to start plugging it in. But we don't say y equals, we say a of n equals because we're talking about sequences here. So there's sequence notation, just like there's function notation. This would be now a sequence notation. And so we have a of n equals the first term, which is negative 11, plus the n minus 1, that's just from the formula, and then times the d there, which would be 2. And so now I'm just going to clean this up, multiply, distribute the 2 into n minus 1. So we're going to have negative 11, and then it's going to be 2n plus a 2n, and then it's minus 2. And again, we're going to combine these two like terms, negative 11, negative 2. We add and keep it negative. And so we're going to have our a of n is equal to 2n minus 13. So that's like our slope is our 2, and our negative 13 is our y-intercept. Plug in 10 now to find the 10th term. So what would the 10th term be down the road? Well, it's 2 times 10 minus 13. So 2 times 10 is 20 first. So 20 minus 13, that would be 7. 7 is going to be the 10th term of this sequence. Let's go ahead and do number 21, this one with fractions on it. And obviously fractions are always a little more challenging. But obviously we can see our first term, there's 9/4. What would the common difference be of this? From 9/4 to 7/4 to 5/4 and so on. You know, since they're all in fourths, it's helpful. So your common difference, you can see it, they are going, are they going down? Well, yeah, this is getting smaller because obviously 9/4 would be like 2 and 1/4. This would be like, 1 and 3/4. This is going to be 1 and 1/4, and then 3/4. So it is going down in the negative direction, getting smaller every time. And it's going down by a half. It's actually going down by a half. And you can see that a little more closely, I think, if you were to put these into more of an improper form or even a mixed number form. You would see that it's going down by a half. So if I was to add a half, or I should say subtract a half from 9/4, a half is 2/4, realize. So if a half is 2/4, 9/4 minus 9/4 minus the half would be a 7/4. So that's how you can see that. It's going down by a half again. 7/4 minus 2/4 is 5/4, and so on. So hopefully you understand that as we move forward. So let's go and just now plug these numbers in, 9/4 and the 1/2, into our formula. So a of n is equal to, our first term is 9/4 plus the n minus 1 times the common difference of this negative 1/2. Distribute the negative 1/2 into the n minus 1. So we're going to get 9/4 minus 1/2 n plus a 1/2. And I'm going to change that 1/2 to 2/4 so that we can combine the like terms, keeping them in a common denominator form there. And so 9/4 plus a 2/4 is 11/4 for our actual equation here. So it's negative 1/2 n plus 11/4. That's what we're going to see for our equation. And then we're just going to plug in 10. So if we plug in 10 for n, half of 10, the negative times that's going to be just negative 5. Half of 10 is 5, but it's negative 5. That's a negative times a positive. So we're going to see negative half times 10 is negative 5, and then plus 11/4. And so we can, change 5 into 20/4 or negative 20/4. And so if I now just combine the top numbers, negative 20 with positive 11, I'm going to take 11 away from 20. It's going to give me negative 9. So negative 9/4 is my 10th term. So as we see here, and we want to keep it in improper fraction form just because that's what our sequences are in. So these are in improper fractions. Our 10th term needs to be an improper fraction. Alright, I did leave these with some easier ones here. There's no fractions. They should all be fairly simple to do. So do 17, 18, and then 20 from here, and then play your, so go ahead and pause it, do those three, see if you can understand, get the equation and get the 10th term, and then play it, and then you can check to see if your answers are correct. Or if you want to play it in small increments and check one at a time, that's fine too. Alright, so hopefully you paused your video and now you're just checking, either checking number 17 or you're going to check all three of them out at the same time. So number 17, there's our 43 is our first term, common difference is negative 5. And so as we plug that in, we're going to see 43 plus the n minus 1 from the formula, and then times that common difference of negative 5. Distribute negative 5 into n minus 1, and now we have 43 minus 5n plus 5. Combine 43 and 5 together, that's going to give us a 48. So your equation, best read, is a of n equals negative 5n plus 48, just like mx plus b there. Plug in 10, so you're going to see negative 5 times 10 plus a 48, that's going to be negative 50 plus 48. So since they're different signs, we got to take 48 away from 50, it's going to give us a negative 2 for our 10th term. They are going down, so as they keep going down there, eventually you're going to get to a small number of negative 2. Okay, so for number 18 next. Hopefully you've done number 18, you got that completed here. We can see the numbers are going up. Our first term is 6, and it's going up by 4. And so we have positive 4 for the common difference. As you plug them in, it's going to be a of n is equal to 6, first term, plus the n minus 1, times that common difference of 4. Distribute 4 into the parenthesis here. So we're going to get 6 plus 4n minus 4, once we distribute that in. And then combine 6 and a negative 4. So take negative 4 away from 6. So that's going to be best read as 4n plus 2. A of n is equal to 4n plus 2. Again, a of n is another way of saying y, or like f of x, or f of n. You can think of it that way. But it's a sequence notation. We want to say it like this, a of n. 10th term, 4 times 10 first right there. And that's going to give us 40 plus 2, which is 42. So your 10th term would be 42. Okay, number 20. Number 20, we can see the numbers are going up. So our first term there is 34, and they are going up by 3. So our common difference is 3, plugging it in, 34 plus n minus 1 times the 3. Distribute 3 into this. We're going to get 34 plus 3n minus 3. Combine 34 and a negative 3. So basically just take 3 away from 34. So the best read is 3n plus 31. So a of n is equal to 3n plus 31. Plug in 10, so it's 3 times 10 plus 31. 3 times 10 is 30. Oops, went the wrong way, sorry. 30 plus 31 is 61. So your 10th term in this sequence would be 61. All right, so let's look at now our last problem, number 22, at the very bottom of 125. All right, so 22 is a word problem. We always try to, connect it to some kind of word problem for a real life context. So in an auditorium, the first row of seats has 30 seats. Each row behind the first row has 4 more seats than the row in front of it. So right there, that kind of sounds to me like an arithmetic sequence. You keep adding 4 more seats for the next row and the next row and the next row. And the last thing there says, how many seats are in the 25th row? So that's really the question that we're being asked, is how many seats are in the 25th row? So it's way further in the back. Now, we can't really tell that just right off the bat. If the first row has 30, how many does the 25th row have if each row gets more seats, 4 more seats every time? So the best thing to do is to kind of think of this as 30 would be our first term in the sequence. The 4 more seats, the 4 there, is the common difference. You're adding 4 every time. And then the 25 would be your n to plug it in. What's the 25th term in the sequence? If the first term in the sequence is 30, what's the 25th term in the sequence if the common difference is 4? So we're going to first just write out an equation, just like we've done before. Sorry about the n here. It's a little strange looking n. So a of n is equal to 30, that's your first term, plus the n minus 1, and then times the common difference, so it's times 4. Distribute the 4 into n minus 1, just like we were just doing. So 30 plus 4n, 4 times n, and then 4 times negative 1 is negative 4. Combine the 30 and the minus 4, so take 4 away from 30, and we're going to end up getting 4n plus 26. So there's our equation. We just now need to plug 25 in for n to figure out that 25th row. So we don't have to keep saying, okay, well, I know the second row is going to have 34 seats because that's 4 more than 30, and the next one's going to have 38, the next one's going to have 42. We can kind of do it the long way, but this way is a little quicker if we can get this equation out and then just do 4 times 25 right there, the a of 25. So the 25th term is 4 times 25 plus 26. So 4 times 25 is 100, and 100 plus 26 is 126. So the 25th row has 126 seats. Let's make sure we write down seats there, because that's what the number stands for. 126 stands for, that's how many seats there are in the 25th row. All right, that concludes our lesson here for arithmetic sequences, and I'll see you on the next one. Have a great day.